Okay, we have here today another integral from the MIT Integration Bee from 2006. This was problem 28. We have the integral of 2 over cosine x minus sine x all squared dx. Okay, there's definitely a few different ways we could approach this now. Like we could just square this out if we wanted. But the way I like to do this is just notice that we have, if we could look at this as having a coefficient of 1 on the cosine and 1 on the sine. And for that case, what we can do is we can kind of use the angle sum formula in reverse, and we can write this as cosine x plus pi over 4. Now it may seem kind of like I pulled this out of thin air, but the thing to notice, the reason this works is just notice that for sine of pi over 4 and cosine pi over 4, we get the same value. It's just 1 over square root of 2. And what we can actually do is we can do the angle addition formula in this really quick. We can see this is going to be cosine x times cosine pi over 4 minus sine x sine pi over 4. And again, this right here is 1 over square root of 2 or square root of 2 over 2, either way. And this here is also 1 over square root of 2. So what I can do is factor this out of both terms, and I can write this as 1 over square root of 2 cosine x minus sine x. So we see that our value for cosine x plus pi over 4 is almost cosine x minus sine x, but we still have this 1 over square root of 2 in front. Well, that's going to be easy to fix. I can just multiply in here by square root of 2 on both sides. Now this cancels, so we have exactly what we have here, cosine x minus sine x. And so the expression we want over here, this is just going to be a square root of 2 in front of our cosine x plus pi over 4. So now we'll just take this and we'll plug this back into our integral. So we're still going to have our 2 in the numerator. And then in the denominator, this is going to become square root of 2 cosine x plus pi over 4. And this is all squared. Then we'll just multiply this out in the denominator. So we're going to have 2 in the numerator, but square root of 2 squared, this is going to become 2 here, and this other term is going to become cosine squared x plus pi over 4. But then we can cancel the 2's. We can bring the cosine squared into the numerator, and I can rewrite this as just secant squared x plus pi over 4. But now this is a really common integral. We can just integrate this. Integral of secant squared is just tangent. And notice we don't need to do any, we aren't required to do any u substitution here because the derivative of this is just going to be 1. So we don't need that, but we can just remember this is going to be our input. And so integrating this for our final solution of this, we just get tan x plus pi over 4, add a plus c, and that's it. And now one note on the solution, this is actually the way they had it in the integration bee, but if you wanted to put it back into having just an angle of x, what you could do is you could rewrite tangent as sine over cosine, use angle sum formula again, and what you get is, doing that, you get sine x plus cos x over cosine x minus sine x. And so, of course, there's a number of different ways you could express the solution. You could actually put it back in terms of tangent again, too. So there you have it, a good integral from MIT 2006. Thanks, everyone, for watching. Have a good day.